Hello, so today we're going to do some number operations with complex numbers, so some arithmetic with complex numbers. So first of all, let's talk about adding and subtracting. When we add and subtract, what we do is we combine the real parts and combine the imaginary parts. So we still do our normal processes of distributing. 2 minus I minus 5 minus 3I minus 5 plus I, so that was me distributing this negative and distributing that negative. Now we see the real parts are 2, negative 5, and negative 5. So these two add to negative 3, and plus that adds to negative 8. And then I take the imaginary parts. So that was negative I, negative 3I makes negative 4I, plus I makes negative 3I. Let's try it again. These are all added, so I don't need to worry about distributing. I add the real parts, negative 8 and negative 5 give us negative 13, plus 1 is negative 12. The imaginary parts, negative 4I, positive I, and negative 3I. So these become negative 3I, plus another negative 3I becomes negative 6I. That's adding and subtracting. What about multiplying? Well, when we multiply, we're going to distribute. So negative 7 times negative 4 is 28. Negative 7 times 7i is negative 49i. 6i times negative 4 is negative 24i. And 6i times 7i is, well, hopefully you know that this is 42i squared. But I squared is also the same thing as negative 42. Oh, sorry, I squared is the same thing as negative 1. So the whole thing is negative 42. So if we wanted to rewrite it the long way, we would do that and then rewrite it as negative 42. Now we combine the real parts. That becomes negative 14. Combine the imaginary parts, and that is negative 73i. Hopefully you're not going to try to distribute this because there's addition inside. This is negative 5 plus 6i times itself. So negative 5 times negative 5 is 25. Negative 5 times 6i is negative 30i. 6i times negative 5 is negative 30i. And 6i times 6i is, we could write it as 36i squared, but I'm just going to go ahead and write it as negative 36 because I times I is negative 1. Combine the real parts and get negative 11. Combine the imaginary parts, get negative 60i. This is one where people get this wrong a lot. People will multiply the insides and say that this is the square root of 48 and then simplify square root of 48 correctly. But you can't just do that when we have negatives, because this is I square roots of 6 times I square roots of 8. Hopefully you agree with that. So this I times I will become negative 1, and then we get negative square root of 48. If you had just multiplied the insides, you'd get 48 on the as the radicand and no negative outside. So you have to make sure that you're simplifying out the negatives before you do any multiplication. So watch out for something like this. So when we do this, we get 4 times 12, 2, 2, 3, 4, 2, 2. So we get negative 4 square roots of 3. And do not get 4 square roots of 3 by doing negative 6 times negative 8 and then taking square root of 48. Here, I gave you very large exponents. You should know your I rules, that I squared is negative 1. Let me write that out. I squared is negative 1. So if that's the case, I cubed is negative I, and I to the 4th is 1. And then we can repeat the process. I to the 5th is I to the 6th is negative 1. I to the 7th is negative I. And this is because each time we're multiplying by I. This pattern repeats every 4. So if I write I equals I, and then I continue out to I to the 8th equals 1, every 4 it repeats. So every multiple of 4 is going to be 1. In other words, I to the 28th is 1. So I to the 30th is I to the 28th times I squared because of the exponent rules. So I to the 28th we know is 1. Same thing over here, I to the 40th. That's a multiple. 40 is a multiple of 4, so this whole thing is 1. So this becomes -1 minus 1, -2. So whenever you get something really large like this, look for the biggest multiple of 4 that you can. Oops. Look for the biggest multiple of 4 that you can, and then use that to your advantage. This last piece is about dividing, and what you need to do when we're dividing is we need to multiply by the complex conjugate. So the conjugate is taking the denominator and negating the second term of the binomial. So 10 plus 7i instead of 10 minus 7i. And then we have to do out the multiplication. 90, 63i, 90i, and -63 over. And we could do out this, but because this is a difference of squared, this is the same thing as 10 squared minus 7i squared, which will be -49. So minus -49 will become plus 49. And this is how it should always work out if you are correctly multiplied by the complex conjugate. So we have 90 minus 63 is 27. 63i plus 90i is 153i. And that's all over 149. Let's try another. Multiply by the complex conjugate, 8 plus 6i. Multiply those out, -16, -12i, +64i, and -48, all over 8 times 8 is 64, 6i times 6i is -36, but we're subtracting -36, so we're adding 36. The numerator, -16 plus -48, is -64, and these two add up to 52i, and the denominator adds up to 100. That is not your final answer because, unlike over here, these three numbers are all divisible by the same thing. In particular, they're all divisible by 4. If you said 2, that's fine, as long as once you divide by 2 the first time, that you check to see whether you can divide by 2 again. So if I divide each of these by 4, I get that, which is our final answer.